Hello everyone. We are a group of fourth year students belonging to the Department of Biomedical Engineering from SRM University, Chennai. I, Arbachina Bora, along with my batchmates Yontan Jamsho, Shan Jalu and Furkan Farouk Lone is doing our final year project in detection of strabismus or squint eye using Adaptive Neuro Fuzzy Interface System or Anfis under the supervision of Mrs. T. Rajalakshmi, Assistant Professor, OG. Strabismus or squint eye is the misalignment of the eye with each other. It is also known as cross-eyed or wall-eyed. It typically involves a lack of coordination between the extraocular muscles which hamper binocular vision. Strabismus occurs in 4% of children, amounting to 130 to 260 million worldwide. The different type of strabismuses are esotropia, eye turned towards the nose bridge; exotropia, eye turned towards the ear; hypertropia, eye turned upward; and hypotropia, eye turned downward. Strabismus, if not cured at a younger age, causes vision loss or impairment. Also, the angle of deviation or squint is very necessary for the correct treatment by the doctor. People with such a condition have problem with work, school and sports. Also, it has a negative impact on the self-image. The already existing literature for the detection of squint eye involves real-time squint eye detection. Here, digital image processing, projection function, half transform and non-linear enhancement and segmentation method has been used. However, the drawback of this method is that half transform makes iris detection impossible. The second method is called the automatic strabometry method. Here also half transform is used. The total calculation time is 2 minutes. However, half transform as again used makes iris detection impossible, and also this method cannot be applied for blurred images. The third method is called the neural network approach. Here, testing and training phase of data is used. The work, however, could not be extended to video images. The main aim of our project is to detect the angle of squint using Adaptive Neuro Fuzzy Interface System or Anfis in MATLAB. Our objective is to detect the various regions of the face and to find the apex of the facial triangle or the Delaunay triangle in order to find the extent of deviation of squint using Anfis. This is the proposed block diagram of our project. Here, detection of left and right eye images is done separately. Various regions of the face like eyes, nose and mouth are highlighted, and subsequently a triangle called the Delaunay or facial triangle is formed with the center of two eyeballs forming the base of the triangle and either the nose or mouth forming the apex. A shift in the apex of the triangle roughly indicates a squint or abnormality in the eye. Edges of the eye are detected and the region of interest, that is, the eyeball, is extracted using half transform. The half transform is a technique which can be used to isolate features of a particular shape within an image. Further, feature extraction is done. The features we have extracted during our project is area, parameter and circularity. Detection of angle of squint using Anfis is done is based on these extracted features. This is the image for a normal eye. Here we have extracted the facial triangle or the Delaunay triangle with the help of markers. Marker 1 is the left eye, marker 2 is the right eye, marker 3 is the nose and marker 4 is the mouth. Here, edge detection and half transform is carried on. Edge detection is done to extract the region of interest, that is the eyeball, and half transform is further applied. This is the squint angle detection. Since there is a normal eye, we do not have any squint and therefore the angle appears as 0. Here we have used graphical user interface to show the flowchart of our program. This is a sample squint image. Here the squint angle is deviated from the normal eye angle. Also, we have again used graphical user interface to show the flowchart of our program. This is the facial triangle or the Delaunay triangle, which we have extracted to show the detection of shift in the apex. Marker 1 is right eye, marker 2 is left eye, marker 3 is the nose, and marker 4 is the mouth. Edge detection is carried out to know the squint iris of the eye. Half transform is then again applied. The formula for calculating a particular squint angle is squint angle is equal to 180 minus cos of length 1 into length 2 into 180 divided by pi. Pi here is 3.14. Length 1 is square root of sum of area to the power 2. Length 2 is equal to square root of sum of perimeter to the power 2. This is the squint angle detection. Since there is a deviation from the normal eye angle, the squint angle we have found here is 2.21351. Also, the graphical user interface is used to show the flowchart of our program. The different features we have extracted for the squint eye are as follows: area 160 mm, perimeter 3.1267 mm, and circularity 0.0611 mm. This is our final adaptive neuro fuzzy interface system or Anfis result. Here, training data indicate the left eye squint angle of all the sample images, whereas testing set indicate the right eye squint angle of the sample images. Both these data sets are used to calculate the overall error value for a set of input abnormal images. In this study, adaptive neuro fuzzy interfacing approach to detect the angle detection of squint eye was carried out for different cases of normal and abnormal subject. The work is carried out in 2 different phases. Then relevant geometric features have been selected, and based on the geometric features, relevant parameters have been extracted. Then, using Anfis, the feature vectors have been utilized in the testing phase to recognize whether the eye is normal or squint, as well as the angle of squint is also calculated. In future, we aim at extending our work to video images. Also, we hope to deduce the relation of additional features that are extracted from the input image. That is, circularity, sum of variance, entropy, contrast correlation, energy and homogeneity with that of squint. The following are the references we have used while carrying out our project. Thank you.